This is checkpoint 1.3, problem number 2. The instructions are factor by grouping. We have the four-term polynomial x cubed minus x squared minus 4x plus 4. So this is four terms because terms are separated by plus and minus signs. Factor by grouping is a common strategy anytime you have four terms. So I want you to keep those ideas in mind. So factor by grouping is typically when you have four terms. So what we're going to do is we are going to look at the first two terms, and we are going to look at the second two terms. Notice how my underlining here, I am trying to be specific with underlining that negative in front of that 4x. I do need to keep that in mind. And we're going to factor out a greatest common factor. So if I look at the first two terms, x cubed minus x squared, remember x cubed is x times x times x, and x squared is x times x. So if I want to know what they have in common, they have two x factors in common. They have x squared in common. So from the first uh, underlined red group, I can factor out an x squared, and that leaves me with x minus 1. If I had three x's and I pulled out two of them, there's one left over. If I had two x's and I pulled out two of them, there are no x's left over, but there is still a coefficient of 1 left over. You could also show division if you find that helpful. You can divide this by x squared and divide this by x squared. Do the division and see what's left over whenever you do your exponent rules. But moving on to the second group, we have a minus 4x and a plus 4. They don't have any variables or x's in common, but they are both divisible by 4. And that first term, the leading term, is negative. You generally don't want your leading terms to be negative. If they are, you factor out a negative. So I'm going to factor out a negative 4. Let me get the right color here. Factor out a negative 4. And we need to see what's left over. Again, if it helps, show the division. Let me see if I can get a different color here. I'm going to divide the first term. I'm going to divide this by negative 4, and I'm going to divide this by negative 4. Negative 4x divided by negative 4 leaves me with a positive x. A positive 4 divided by negative 4 leaves me with a negative 1. So that's what it looks like whenever you factor this out. Now, I'm going to underline our new terms in blue. We have a blue term here, and we have a blue term, get out of here. We have a blue term here. They are separated by this minus sign. Sometimes it's a plus sign. In this case, it's a minus sign. Those two terms have something in common. If you look at what's underlined in blue here and what's underlined in blue here, and you look at, what they have in common, I see that they both have an x minus 1. So I'm going to factor that out. I'm going to factor out an x minus 1. And then inside of these big empty parentheses that I've just created, I'm going to write down what's left over from those blue underlines when I pull out and get rid of the x minus 1. I still have this x squared from the first blue term, and I still have this minus 4 from the second blue term. So that is going to be x squared minus 4. So we have successfully done the factor by grouping technique. Now, we have not fully factored this thing. X minus 1 is linear. It's linear because x isn't being squared or cubed. It has no exponent. It's an exponent of 1, so that can't be factored. X squared minus 4 possibly can be factored. It's x squared, so it's a quadratic. This happens to be a difference of squares. 4 is a perfect square. So I'm going to recopy the x minus 1 because there's nothing that I can do with that. But the difference of squares, it's a difference of squares. Difference means that there's a minus sign. Difference of squares because 4 is a perfect square, just like 9 and 16 and 25 and 36, all perfect squares. One parentheses will get a plus sign, one gets a minus sign. They each get an x, and they will each get whatever the square root of 4 is. The square root of 4 is 2. And so here we have now fully factored the polynomial. That is what we're looking for.